Okay, ladies and gentlemen, welcome back. This is the last part of topic 9 and 10. This is going to be Roman numeral 4, glaciers, and it should be fairly quick. So, what is a glacier? Right? A glacier is a large mass of snow and ice that advances under a force, and the only force that we talk about is gravity. So, glaciers, you get snow, you get rain, you get ice that builds up on the top of a mountain, and it slowly is pulled down by gravity and it creeps forward. So when did we see glaciers? Right, starting roughly about 2 million years ago and lasting to roughly 11,000 years ago, the Earth has experienced several different periods of glaciation, meaning that most of the northern hemisphere was covered by ice. In fact, some of the ice was over 1 mile thick. Okay, so picture an area starting at the North Pole and working their way all the way down past New York, saying almost as far down as the central part of the United States was covered by glaciers. So about 20,000 years ago was one of the last periods of glaciation. New York was covered and Long Island was formed. In fact, some of the features that we're going to talk about in a moment actually can be found all over Long Island because Long Island was created by glaciers. So, quick reminder, all right? What type of valley shape do glaciers create? Glaciers create that nice U-shaped valley. Rivers, on the other hand, create a V-shaped valley. We talked about both of these in some of the earlier videos. So the first thing about a glacier is called a moraine. So if you picture a glacier is like a giant snowplow. Right? Picture the snowplows in the winter pushing snow, and it also picks up every single thing with it. And that whole front of the snowplow is going to create a mound. That mound that is left when the snowplow leaves is that giant mound of snow, ice, rocks, dirt, anything that it picked up. That is a moraine. So rock material is carried by the glacier and it is deposited when it retreats. Right? So we can see here the glacier on the left side pushed forward, right? And it created this kind of bump of material here. That's a moraine. The moraine indicates the farthest point that a glacier moved. Next, we have what is known as till. When glaciers pick things up, they don't care if that material is big or small. Unlike rivers and waters, when water is moving fast, it carries bigger materials. When water slows down, it's going to drop those bigger materials off and only carry small stuff. Glaciers carry everything, big, small, it doesn't matter. If it's in front, it gets picked up. All right, and it is then deposited. So glacial till is always unsorted. In fact, that key word right there, whenever you see the word glacier, its material will always be unsorted and unstratified, meaning no layers. So picture just a mess of material, big, small, intermediate, everything all mixed together, no sorting. Right? You can see big and small material all mixed together. Next, we have outwash. Okay, so when a glacier melts, that water is going to wash outward from where the ice still is. Now you have a different sort of sorting. Now you're going to have things that are sorted. This is like that horizontal sorting. As the glacier melts, closest to the glacier, you're going to have your fastest moving water, so that's where your bigger particles are going to be. The farther away you get from the glacier, the smaller the particles are going to get. This is horizontal sorting, and I'm just going to write it here. All right, I'm going to abbreviate. All right, horizontal sort. Okay. Next, we have an outwash plain. This is what's actually created by this outwash. Essentially, this is what all of the south shore of Long Island is. When the glaciers pushed forward, they stopped right about the center of Long Island and they started to melt. Now we have rivers and streams that slope down from essentially where the expressway is on Long Island, straight down to all of our beaches on the south shore. So essentially from northern Brentwood all the way down to Bayshore. Bayshore is going to be located on that outwash plain. All right, so now the streams are going to flow slowly because these deposit and it's going to make deposits that are going to be like this horizontal sorting, and they're going to go all the way out past the terminal, meaning the last moraine. Okay, beaches have your finest sediments because they are farthest from that moraine, which is the biggest material. All right, so you could see kind of here, these are your bigger particles, and then as you move farther away, all this down here is going to be your finer sand. Right? Then we have what are known as kettles or kettle lakes. These form when giant chunks of ice or blocks of ice are broken off the glacier, right? As it's retreating, they're then buried under the sediment, right? And they're allowed to melt, so they create a lake. This is what you see. Here is this nice U shape created by the glacier right in here. It dropped off a chunk of ice. That ice melted, but because it compacted the soil underneath it so much, now you have a lake. Whenever it rains, all of the rainwater is going to rush down the sides here and fill this hole that was once a mass of ice, but now it's a lake. Drumlins, these are really cool. We can actually see these in upstate New York. They're kind of teardrop shape, right? And they look like a hill. It's kind of like in this flat area where you wouldn't expect a bump to be. All of a sudden you have this weird bump shape. It's known as a drumlin. As the glaciers retreat, they drop off chunks of sediment, right? And those chunks of sediment actually look kind of like a teardrop, and they point in the direction that the glacier moved. So here's a picture of it. Right? This is a picture of a drumlin. You can see here is this kind of sideways teardrop shape, right? The glacier pushed forward, right? It left this kind of shape behind, and then it retreated, causing this kind of teardrop. And you won't have just one of them. You'll have a series of them. And if you travel to the central part of New York, you can see quite a bit of these. Right? Then we have what is known as a glacial erratic. We actually have these here on Long Island. If you ever get the opportunity to travel out to Stony Brook University, you're going to see that all throughout the campus, you've got kind of these flat areas. Now some of them are even paved into parking lots, and all of a sudden you're going to have this giant boulder, right, or this large rock that looks like it doesn't belong there. Well, it doesn't. That is known as a glacial erratic. Again, remember what I said earlier, glaciers pick up everything, they also drop everything off, but they don't care about the size. If it's the last thing to get picked up, it's going to be the first thing to get dropped off, and vice versa. If it was picked up early in the glacier's life, it's going to be dropped off last. It does not matter. Whatever is picked up first is dropped off last, and so forth. So glacial erratics are just large rocks that are dropped off or deposited by glaciers as the glaciers melt. Right? So you can see here, this is a giant boulder in an area where you don't see a whole bunch of other really large rocks. That is known as a glacial erratic. Okay, so that is the end of our notes on glaciers. Kept it really, really short. Right now, just go on and answer the Castle Learning questions. As always, if you have any questions, comments, or anything, please reach out to me on Teams or Remind, and I will gladly get back to you.